Alright, in this lesson we're going to try and take a look at polynomials, roots of polynomials, and things that well, we can factor, and we can take a look at the properties that they contain. Okay. First of all, we got to talk about polynomials. A polynomial of degree n is a function of the form p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a1 x plus a0. N is equal to a non-negative integer, and a n does not equal 0. Alright, here's the English version of this. A polynomial is a bunch of terms, okay? N is the number or the highest power, think of it as, okay? So if I want something to the fifth power, it's x to the fifth, okay? So n is 5. Okay, the number in front are the coefficients. So think of a number like whatever you want to say. I'll call it 7. Okay? Well, the next term, a sub n minus 1, that's the term below it. So instead of 5, this is, 4. Okay, so the fourth, is whatever your coefficient is. I'll call it a number. 10. X, 5 minus 1 is 4. That's first power. Okay? Plus, you can even have a 0 in front as a coefficient. X to the third. Plus x squared, even minus 7x. So that's the a1 is the 7. X is there. Plus a0, which is our constant term, or whatever you have left over. So like 8. Okay? These are the forms of a polynomial. Polynomials have integers upstairs. In fact, they're non-negative integers, so positives. Okay. A lot of time we also are going to say x sub 0 or x to the 0. Remember, is 1. Could be there too. Okay. So the families we should know, and the degree and the leading coefficient are things we should be aware of. Okay. The degree is the highest power. Okay. So it's easier to see here. The highest power in this thing is 4. On this one, it's just 3. This one is 2, this is 1, and believe it or not, this is 0. Okay. The family names are things that some should be familiar, some are newer. This is a constant. Well, this one is linear. The second one, or the third one down, is the quadratic. Yes, that's a Q. Okay, for those of you who forgot cursive. Right? Quadratic, these are the threes we should know. Notice the quadratic's power 2, linear's power 1, constants are power 0. The third is the cubic. Think of 3D. And the fourth is the quartic. Okay, we usually don't use that word. We usually just call them polynomials after 3. But be aware of it. There's the fifth degree, which is the quintic, but 6 we don't even start. The leading coefficient is just the number in front of the biggest term. So like in this one, it's just -5. In this one, it's the number in front of the x term, which is 3. The number in front of x squared for this one is 1. The number in front of this one is -10. Yes, it can be negative. And then 2. Okay. What we're going to realize with polynomials, it's all about who's the bigger guy, all right, or girl. The biggest one wins. It takes the properties of the big one overall. The rest of it kind of just is too small. It loses. Okay. Think of 100 squared, which is 100 times 100. Which is 10,000, and 100 cubed, which is 1,000,000. Okay, what would you rather have, 10 grand or $1 million? So, polynomials do have nice little things. First of all, it's continuous. That means there are no breaks. Like the hyperbola has a break in it, like that. You can draw it without picking up your pencil. It's also smooth, okay? There are no corners. Kind of like the absolute value. It has one, that's bad. Okay? So look at the graphs. I'm just taking a looking at the polynomials, and we're just going to look at the degree. X squared, x to the fourth, x to the sixth, and x to the eighth. If you look at these, all of them, as you go, they all go up to infinity in both directions. It's not a coincidence that all the even ones do that. Think about it. An even squared is going to be, well, an even squared is just even. Okay, but an even number that's positive and you square it's still positive. But an even power, sorry, I should be using the word power. An even power, take a negative and raise it to the second. An even makes it from a negative to a positive. Okay. Think of it like negative 2 squared becomes positive 4, or negative 2 to the 4th becomes 2, 4, 8, positive 16. Okay, so you notice it loses the negativity. However, if it's an odd power, you keep it, right? Especially in the negative region. Okay, so we're going to take a look at what happens overall in the end behaviors. Okay, that means as you go right and left, what do the graphs do? Right? And the end behaviors are read like this. If I say x goes to infinity, think of it becomes really positive. Well, x to negative infinity becomes really negative. Okay? So, you're going to see that there's certain properties. Okay? Because I was saying how about the big one winning, we have to think of it like that too. Alright? So it's going to take those properties on. So let's just take a look at x goes to 0 where n is 0. Okay? So think of 1 times x to the 0. Well, this is just y equals 1. As it gets really large, well, it's always 1. However, it gets really negative, y equals 1 is still just 1. Okay, think of the line. It's just 1. It's that dotted line. It goes, it's always 1 that way, it's always 1 that way. If we look at n even, think of a quadratic. It goes like this. As you get really large, that means you go really to the right, it goes up. And that's positive infinity. If you go to the left, well, look at my graph. It still goes up. It's positive infinity. And it's always going to do that if it's even. Even if it's got extra stuff, plus x cubed, x to the 4th wins. So that's why it's only the highest power we're looking at, and that's why it's a big deal. Right? The other piece is if it's odd, well, if we look at odd, let's do x cubed, it goes up if you go to the right. But if you go to the left, it makes it real negative, so it goes negative infinity. All right. The only way these are going to change is if you put a negative coefficient on them. Then it swaps the order. So if this was, think of x squared positive, you put a negative x squared, it makes them both negative. Okay. So the coefficient, that's why I say coefficient is 1. If it's negative, then these swap to the opposite signs. Okay. So just look at the biggest term, the leading term. Right? So let's take a look at this one. I'm going to do it by the graph and by the idea of what the polynomial is. X cubed, odd. It's odd, it's infinity and negative infinity. Okay, as it goes to infinity, it goes to infinity. As it goes to negative infinity, it goes to negative infinity. They stay the same, right? They're different. Okay, I know it's positive because the number in front is positive here, and then over here it takes that sign. Okay, it stays negative infinity, positive infinity. If you look at the graph, if we go to the right, it goes up. It goes to positive infinity. When I go to negative infinity, this goes down. So it's negative infinity. So you see the picture does tell a lot. Looking at this one, this is x to the 12th and 2x squared. Well, if I look at the power, this one's irrelevant. And I just look at this. No, it's even. Evens are the same. Usually they're infinities. However, my picture says not. Well, that's because of the negative coefficient. Well, negative says, well, this whole thing is always positive, but then make it negative. So they're both negative infinity. Okay. So these are some of the basic properties of polynomials.